Hi everyone! Today we're going to talk about an intro to polynomials. So before we get into polynomials, we probably need to know what those are. So our vocabulary today are going to be polynomials, monomials, and like terms. We actually have had experience with like terms before. We know that those are the terms that have the same variable and the same exponent power. But we're going to really see those today, especially as we get into adding and subtracting polynomials. We also need to know that a monomial, mono meaning one, is an expression of the type a to the xnth power, where a is a real number, constant, and n is a non-negative integer. What? Basically, it's a number, it's a variable, it's a combination of a number and variable. So examples of monomials would be something like 2, 4x, or something like 2x to the third power. Any of those would be considered monomials. A polynomial is a monomial or a combination of sums and or differences of monomials. So it's these same things, 2, 4x, 2x to the third power, and it's actually going to be something like 2x to the third power plus 4x plus 2. So that's a polynomial. It's going to be many of those monomials. And then we have our like terms. And like terms, we know, have the same power and variable. So if I have something like 2x squared and 4x squared, those are going to be like, not just because they have the x, but because they also have those same exponents. Whoops, there's that too. There's a lot of operations that we can perform with polynomials. The most basic is going to be adding polynomials. And we've actually done this before when we started combining like terms when we were simplifying expressions. We just didn't know sometimes that we were using polynomials. So all we're going to do when we see our polynomials, they're separated by the parentheses, don't let those scare you, is just combine our like terms. So we see a negative 3x to the third and a positive 4x to the third. So we know that that's going to be a positive 1x to the third, or just x cubed. Then we have a 3x to the second power. I don't want to combine that with anything because I don't see anything else that has an x to the second power. So I'm just going to put plus 3x to the second power. Then we see that we have a 2x. There's nothing else like that 2x, so I'm just going to add 2x. And then we see that we have minus 4 and plus 2. And negative 4 plus 2 is going to be a negative 2. Notice the way we write this also, our exponents go from largest to smallest. This is called descending order. And when we're working with polynomials, we actually like to write things in descending order. It means the order of the exponents is getting smaller every single time. So hopefully that example of adding polynomials was pretty simple. Let's look at our next example. It's going to be not only just a little bit longer, but it's also going to include our favorite fractions. So if we look, first thing we want to do is try and get all of our like terms together. That means like variables and like exponents. So we have a 2/3 x to the fourth minus or plus a negative 1/3 x to the fourth. So we know that 2/3 and 1/3 already have the same denominator, so we're just going to be able to just add these together, or in our case, subtract them. So we end up with 1/3 x to the fourth. Our next polynomial term is going to be something with to the third power, or something with an x cubed. So I don't see anything else on our left side with an x cubed, so I'm just going to have this plus 5x cubed come down by itself. Then if we look, we have a positive 3x squared and a negative 3x squared. We know that a positive and a negative 3x squared is going to be 0, so we can just get rid of both of those. They'll cancel out. Then we can see that we have a negative 2x and a positive 3x. Well, negative 2 plus 3 gives us a positive 1x, or just x if we don't want to include that coefficient. And then the last thing we see here is going to be the plus 1/2 minus 1/2. Again, these are our constants. They have the same denominator, so all we have to do is add the negative. But since they're going to be the same thing, we know that those will also cancel out. Therefore, this 1/3 x to the fourth plus 5x cubed plus 1x is going to be our answer. Again, we notice that they're written in descending order. 4, 3, there's no 2, 1, and then no constant. All right, now it's time for you guys to try some on your own. So why don't you guys look at problems 1 and problems 2 and take a minute to pause the video and try to work these on your own. Hopefully these are the two answers that you got. If not, go back and check your work. Again, we're working with these negatives and combining like terms, so we will have some issues with adding and signs. The next thing that we can do with polynomials is subtract polynomials. So what we're going to do is just solve these the same way. We do want to do one of two things. We can either rewrite our problem, which is what I'm going to do, or we have to be very conscious of that subtraction sign every time we subtract. So I'm going to go ahead and distribute this negative. This is what we would do if we were simplifying expressions, and rewrite my problem just so I can see what I'm doing. So I actually have 9x to the 5th plus x cubed minus 2x squared plus 4 minus 2x to the 5th minus x to the 4th. A negative times a negative we know is a positive 4x cubed, and a negative times a negative is a positive 3x squared. So I rewrote that problem. There's no parentheses, so now I can go ahead and combine my like terms. So what I notice here is that 9x to the 5th is going to be like negative 2x to the 5th. So that's going to give me 7x to the 5th. Then if I look, I can see my next exponent in descending order is going to be negative x to the 4th. There's no other x to the 4th, so I'm just going to go ahead and bring that down. We next have our x cubed and our 4x cubed. So again, remember that has a coefficient of 1, so this is actually going to be a positive 5x cubed. Then we can see that we have our negative 2x squared and our positive 3x squared. So a negative 2 and a positive 3 is going to leave us with a positive 1. Again, we can get rid of that invisible 1 coefficient if we like. X squared. Then we look, we have 5, 4, 3, 2. We're looking for any kind of x's. I don't see anything, so the last thing I'm going to do is just bring down that coefficient of 4. Again, subtracting polynomials, pretty simple as long as we know how to add polynomials. So let's look at example 2. On example 2, same thing. First thing we want to do is go ahead and distribute this negative sign to every single term within our polynomial. So when we do that, we're going to end up with x cubed plus x to the 2nd plus 2x minus 12. Our negative in our negative is a positive 2x to the 3rd. Our negative in our positive is a negative x to the 2nd, and our negative times our negative 3x is going to give us a positive 3x. Now that we've done our first step of distributing that negative, we can go ahead and combine our like terms. So let's go ahead and do that. My largest exponent here is x cubed, so I know that this is going to be a 1x cubed plus 2x cubed, which will give us a 3x cubed. Then we look, we have a positive x squared and a negative x squared. Well, those x squareds are going to cancel each other out. They're gone. So our next terms that are like are going to be 2x plus 3x, which will be a 5x. And then our last term, which has nothing like it, is going to be minus 12. So our answer is 3x cubed plus 5x minus 12. Again, written in descending order of our polynomials. All right, so why don't you guys try some on your own? Why don't you look at example 1 and 2, try those on your own. Go ahead and pause the video now. Hopefully you got both of these answers. Again, subtracting polynomials, pretty easy to do if you know how to add polynomials. And again, don't forget that distributing. So now we've gotten to multiplying polynomials, and we're actually going to see this in two parts. So our first part is going to be multiplying a monomial by actually another monomial, and then multiplying a monomial by a polynomial. So our first two examples are going to be monomial times monomial, and these should feel pretty easy for us. We've actually done this before. So all we're going to do, and it does not matter when multiplying about the coefficients. So our exponents can be different. And let me write that. Okay, so now that we know our exponents can be different and we remember our law of exponents from our law of exponents video, we're just going to go ahead and multiply. So 3 times 4 is going to be 12. And when we multiply exponents, x to the 5th times x to the 2nd, we remember we have to add them. So we actually get 12x to the 7th. Okay, this is going to be a negative times a negative, so we know our answer is going to be positive. 7 times that invisible coefficient of 1 is going to be a 7. And our exponent of this y is the invisible 1. So y to the 4th times y to the 1st is going to be y to the 5th. Hopefully you remember our laws of exponents because that's directly related to multiplying a monomial by a monomial. Okay, so now example 3 is going to be where we actually multiply a monomial by a polynomial. And this is going to seem very familiar to us as well because all it is good old distributive property. So whenever I see this, what I can go ahead and do is just distribute that 2x to everything within those parentheses. So 2x times 5, 2 times 5 is 10. X times x is going to be x to the 2nd power. Remember, those each have exponents of 1. Plus 2 times 3 is going to be 6, and we're just going to keep that x attached to it. So 10x squared plus 6x. All right, our last example, example 4, is probably going to be the trickiest, not because the math is super hard, but because there's just so many terms here. So let's look at that example 4. First thing we know we're going to do is, again, distribute to every single term within those parentheses. So negative 2 times positive 1 will give us a negative 2. X squared times x to the 3rd gives us x to the 5th. Negative 2 times negative 7x squared is going to give us a positive 14. So our negative 2 times our 1 will give us a negative 2x squared times x to the 3rd gives us x to the 5th. Negative 2 times a negative 7 gives us a positive 14, and x squared times x squared gives us x to the 4th. So our next term, negative 2x squared times 10x, well, the negative 2 times the positive 10 gives us a negative 20. Remember, our exponent of this x is going to be 1, so x to the 2nd times x to the 1st is x to the 3rd. And we finally get to our last term. So negative 2x squared minus 4. So all we have to do here is just multiply those two numbers. A negative 2 times a negative 4 is a positive 8. And we're just going to attach that x squared to it. When we multiply like this, if everything's already in descending order, what we notice is our answer is going to be in descending order as well. All right, now you try some on your own. So try these 3, multiplying monomials by monomials and monomials by polynomials. Take a moment to pause the video now. How do we do on that? Hopefully we got these answers for 1, 2, and 3 of multiplying monomials by polynomials. Okay, so we're finally here, part 2 of multiplying polynomials. And this is where we multiply polynomials by binomials and polynomials. What? Don't worry, we got an easy way to solve all of these. So the first thing we're going to do is take a look at this example 1. Anytime I multiply polynomials, I like to use a method that I call the box method. This is going to come in handy later on when we see factoring polynomials. So it's kind of nice to know now. So all I'm going to do is I see my two polynomials, y plus 2 times y plus 7. I'm just going to make a little box that's going to be 2 by 2 because each of these have 2. So since each of our polynomials have 2 terms, I'm going to put that for each box. So y plus 2 and then y and 7. Now I'm going to go ahead and multiply just like I would a Punnett square. Y times y is y squared. 2 times y is 2y. 7 times y is 7y. And 2 times 7 is 14. What I notice whenever I have my box method here is on the diagonal I have my like terms. So when I write this, of course in descending order, it needs to be y to the 2nd power plus 2y plus 7y, we know is 9y, plus 14. So when we use our box method, we have everything we need exactly in the order it needs to be in. So let's try another example of a binomial times a binomial. Again, because I have 2 terms here, I want to make a box that's 2 by 2. This time we have a negative, so I want to put that negative here. So 2x and a negative 3, and a 3x and a negative 5. Then all I'm going to do is multiply. 2x times 3x is 6x squared. 2x times negative 5, negative 10x. Negative 3 times 3x is negative 9x. And negative 3 times negative 5 is a positive 15. Again, what I notice on my diagonals is I have my like terms. So I'm going to write everything that I need to in descending order. 6x squared, negative 9x and negative 10x is negative 19x, and then plus 15. Okay, so now these are our toughest examples. Polynomials and binomials being multiplied together. So if I look here at my example 3, I have x to the second plus 3x minus 4 times x to the second plus 5. Again, because we have our great box method here, we're going to continue to use that. I actually like to have my longer terms on the top, so I'm going to go ahead and put the x squared, the 3x, and the negative 4 there. And I'm going to have the x squared and the 5 on the side. But again, however you want to do that, whatever order you want to multiply in is going to be fine. So x squared times x squared is going to be x to the 4th. X squared times 3x is going to be 3x to the 3rd. X squared times negative 4, negative 4x squared. 5 times x squared is 5x squared. 5 times 3x is going to be 15x. And 5 times negative 4 is going to be a negative 20. So we're actually going to run into a problem right here. If we look, because we have some missing exponents in our descending order, we're not actually going to have like terms on our diagonals. There are like terms here, they're just not on the diagonals this time. So I noticed that 5x squared and negative 4x are my like terms, and that's it. And that's because we had such a large space between x squared and 5. So when we combine our like terms, we should get, again in descending order, x to the 4th plus 3x to the 3rd. 5x squared minus 4x squared gives us a positive 1x squared. Again, we can not write the 1 if we don't want to. Plus 15x minus 20. Ran out of room there. But there's our answer. All right, let's try one more example together, and then I'm going to have you guys try some on your own. So our last example, example 4. Again, I have a 2-term polynomial, a binomial, times a 3-term polynomial, a trinomial, and I'm going to make my box to suit that. Probably should have written all my terms first, but I didn't. Again, because we see that we have an x squared and then it goes straight to the constant, we don't have that x in between, we kind of already think that our diagonals aren't going to have those like terms. But let's see what's going to happen. So 3y squared times 2y cubed is going to be 6y to the 5th. So important to know those laws of exponents. 3y to the second times negative 2y is going to be negative 6y cubed. 3y squared times 5 is 15y squared. Negative 7 times 2y cubed, negative 14y cubed. Negative 7 times negative 2y is positive 14y. And negative 7 times a positive 5 is a negative 35. So again, like I said, we actually, surprisingly, whoops, sorry about that, have like terms here on this diagonal. So that's kind of nice to have. And next, we're just going to write down our answer, of course, in descending order. So I have 6y to the 5th. Negative 14y cubed and negative 6y cubed is going to be a negative 20y cubed. 15y squared plus 14y. And I'm hoping that I'll have enough room to squeeze that minus 35 in there. And I barely do. So that's going to be our answer. Now, why don't you guys try some on your own? So take a moment to try 1 and 2 on your own. Go ahead and pause the video now. Did you get these answers? Hopefully you did, so you guys can be polynomial masters. Just remember your box method and there's nothing to it.